starting position for horizontal, for shoulder, horizontal abduction and abduction is a T position. So the humerus is to be at 90 degrees of abduction. Okay? Horizontal abduction is going to be a movement from here, going away from the middle of the body. Okay? And is that a big or a small angle?
A big angle. Well, a small angle.
If we started over here,
It's just a small one.
it's a very small angle. Is it going to be more or less than 90 degrees?
Less.
Right. Okay. Now, abduction is going to be movement of the humerus towards the body. Abduction is going to be all the way that way. That's horizontal abduction.
Mm-hmm.
Is the angle going to be bigger than 90 or so is it smaller?
Bigger.
Bigger, right. Okay, so now you know, if you can relax your arm for a second. So now you know that the angle for abduction is going to be small, be less than 90. And for deduction, it's going to be a larger angle. It's going to pass 90. It's going to be more. It's going to be 100, 150, something like that, just to get you started. But always starting from this T position. Now the issue is, how do we line up the axis, the stationary arm and the moving arm? We know the moving arm is the humerus. Okay, we know that we've got to line up the moving arm with the shaft of the humerus. The axis is where?
On the acromion?
The acromion, exactly. The acromion is where the axis is. Now what could be a compensatory motion when Gabby tries to adduct? How do you think she could compensate if she's trying to show you more than she has? The trunk is rotating. You see that? See how the trunk rotated? And then if she's abducting, she could try and compensate by rotating her trunk in the same direction. Do you see that?
Yes.
So we've got to count and think, okay, she might do that. So the way that I'm going to line up my axis, my stationary arm, is I'm going to imagine that my stationary arm is, it's going to connect an imaginary line between the two acromions. I'm going to connect them together so that when she rotates, I can reposition my stationary arm on this imaginary line connecting the two acromions. There is another way to measure, which is with the stationary arm pointing in a different direction, but I don't think that's as reliable. If we think about connecting the two acromion together with an imaginary line, regardless of whether she rotates, I can reposition my stationary arm. Now the problem is, my stationary arm, to connect this to the acromion, is going to cut through her neck, and I can't do that. So I've got to rethink everything, and I'm going to reposition my, we're going to start off in this position. What I'm going to do is I'm going to position my goniometer a little bit away from all the structures in parallel. So my axis is now parallel to her acromion. My stationary arm is parallel to the line that's connecting the two acromion, and my moving arm is now parallel to her humerus, and she's starting at this one. It's a 180, but it's a 0, okay? Now I'm going to ask her to horizontally abduct. So she's going to go in this direction. And I'm going to reposition. I'm going to check to see where my axis is, parallel to the acromion. I'm going to check to see that this imaginary line that's connecting the two acromion, that my stationary arm is now parallel to that. And I'm going to move my moving arm in line and parallel with her humerus. You can relax. Now I'm going to read the small angle. Sorry, I should have pinched my goniometer, but from here to here, or from here to here, it's the same angle. So this angle over here started at 0, and and ended at 30 degrees. Okay? And I'll do the same for Adduction, but my moving arm will move in a line that's parallel. So just quickly show you on demonstrate. We'll start in the same starting position, and I'll get it to Adduction. And now let's say she compensated a little bit. I turn the drum, so I can reposition, I'm going to realign my axis, my imaginary line connecting to the chromium, and now I'm going to reposition the moving arm in line with the humerus. You can relax. Okay, and now measuring the angle. This started over here. Okay, this was turned over here and it moved past 90, another extra few degrees. So if I reach 0, 10, 20, 30, 40, 50, 60, 70, 80, and